Welcome back, everybody. We're going to move to a different phase now. We're going to hear from the corporate world on our theme today. And our first speaker, very happy to have here today, Dave Trutch. Dave is currently a technology director in the Digital Innovation Organization for BP, DIO. So we're going to get the digitization view from big oil and gas. Now, we're very fortunate to have Dave here today. BP has taken a leadership role in the oil and gas sector on this topic. And Dave is very a fitting speaker for this, not only being part of the DIO organization, but prior to his assignment in this role, he spent a number of years in BP in more general IT types of functions, but always with the objective of connecting the digital with the physical real world, which is certainly critical for a company in the oil and gas sector. And for further background, Dave is a physical chemist by training, so again, that link to the real world is from his history, and we all know chemists can do anything. With that, let's welcome Dave.
All right, well, good morning, everybody. Just to add what Jim said when he asked BP to present here today, and we've been a member of this particular activity in MIT for many years. Jim actually asked my boss, Morag Watson, the VP of Digital Innovation, to come, and he said, you would be our dream. So if Morag is the dream, I'm your nightmare, so I'll apologize in advance for that. I've only got 15 minutes here to give you an overview, and some of this will be my opinion, so I'll forgive you for that in advance. I'll try and point out when it's just my opinion versus a viewpoint from the company or stuff. But it is a broad brush thing around this whole word of digital. And unfortunately, I think sometimes when new hype comes out, people create new words. So I noticed on our slide it says digitalization. I have no clue what that really means. And I think that's been part of the challenge. What does digital mean to a company like us, a very heavy industrial thing? So if we look at kind of a few decades ago, one of the interesting things that changed, I think, in the world of IT and digital was a switch from innovation occurring in corporate. So it was businesses, companies that seemed to be the ones to innovate. We had our own R&D groups and things. And all of a sudden there was this massive shift to consumer. And consumer did some very, very good things for us because it actually proved out that these things could scale. They could scale dramatically, they could scale quickly, they could die quickly. Very interesting challenge, and when you're trying to work with a company like ours whose cycle times are 5 to 10 years, and we see something 6, 8, 12 months dying, how do you make a decision on what to invest in and what to do? So there's this massive change in the innovation space. So not only did it create this dramatic pace of change in the word digital, but it created a cost reduction, a dramatic cost reduction. So years ago when we were doing things that we called digital, we had to bear the cost of the infrastructure, of the selling of stuff, about the ability to capture and move the data, some of the things you see now. Now, all of these things you saw just prior to this, who wouldn't say they aren't valuable to any oil company or any industrial company? So I applaud Marcus for having put this out here. He made my job so much easier. Because all that you saw from those startups is obviously what we're interested in. And they're showing us where they're starting. They're not showing us where they're going. So that's a bit about where we're going to, I'll try and take you a little bit here. But they're showing us where can we actually start on this whole different world of it. So that's just a bit about what's that word there. So rather than say, do you believe transforming the world is occurring in the digital space? The answer is yes, we believe that. The world is being digitized by all kinds of ways, heavily by consumers. So I can't tell you how much of our kit and our operations are already probably being captured in videos and camera images and drones flying around now, and in high-res kinds of things from people just out for touristy things or people things. So there's a whole notion of digitizing the world through all of these other kinds of devices, which really means there's access to unprecedented amounts of data. And so when we started looking at that, one of the things we started looking at, well, who is being transformed? And there was always that reluctance to say a heavy metal industry could be transformed dramatically. It was always that it seems to be the companies that started out more working in digital world would see transformation. And then along comes Rio Tinto, and I met a lady from Rio Tinto here. They already started to show there's a dramatic change that occur in transforming the way you do mining by going digital. So their whole notion of autonomous and remote operations really intrigued us because that was hitting closer to home, much closer to home, yet they were making it work and they were being able to do these kinds of things with digital mechanisms. And one of the big premises about Rio Tinto's story was that they actually felt they could not process enough ore to make enough profit with the leases they had unless they went a dramatic new way. So it was about somehow trying to figure out a whole new way of managing that, and that was autonomy that came into place. So what we decided to do was take a look and say, okay, if this is what's really going on in the world, then what does this mean to the scale of where we can transform? So let's remember, from our viewpoint, at least from BP's viewpoint, we've always been doing some things digital. Quite spotty. We do a lot of seismic. That's absolutely digital. We've got one of the top 5 world-class HPC centers. I can't even remember now what our petaflop count is, or teraflop count, or wherever in the hell we are now. But we're certainly using that, and we did some dramatic things in the digital environment there. We've done some things in the optimization world. We've done some things in terms of digital rocks that we've seen. So there's a lot that we've understood how to do in the digital frame, but it was very spotty. Is it transformational? Is it across the company? And that is really what we are saying is true now. So we are talking about this as being profound and transformational change. So it's more than just marketing words. It is actually a belief that the entirety of our company can change from top to bottom and across its entire breadth. Every aspect of what we do could actually benefit or detriment from what we see happening to this whole world around digitization. So what started us a bit on this journey, where it started to become a corporate viewpoint and a belief that this is actually corporate-wide, was we do a study called the LTTV, which is a long-term technology view. And a few years back, one of the results of that study was that the digital technology frame is the one that's going to contribute the most to the next 20 to 30 years of the sustainability and change of an oil company. Kind of surprised a lot of our engineers and physics communities, because that's where our foundations are. First principle kinds of physics and engineers, because we're doing PVT, we're doing these kinds of things. So all of our stuff was around first principle kinds of science. All of a sudden this thing called digital comes up, which is all data driven. Huh? How the hell does that empirical modeling fit with first principle modeling? So that's one of our challenges we still have in a cultural change. I'll mention that in a bit. But what we then said is probably the best way to lens this is to look at it in 3 vectors. One is, what does it mean to transform the company? What does it mean to disrupt the company? And what is it for new opportunities created? So in terms of transformation, for example, you heard some stories here, and you'll see some of the notions of the optimization and the predictive maintenance. Well, we've been working in that world for a while now, but we're starting to see ingestion of new data and algorithms and new approaches that are not these first principles or codified text approaches. So we're seeing a dramatic change in our optimization routines. We're seeing things in our predictive maintenance routines that are out there. So these are transformational. One of the biggest changes we're seeing right now is in our inspection and monitoring world, where we're, through these technologies, we're actually transforming our inspection and monitoring activity from an observational science to a quantitative science. So I always like to think of us as actually astronomers in that sense. So if you look at the insights that have come now from astronomy, going back to first principles, I think it's a great analogy of how the astronomers are challenging the physics communities and the theoretical physics communities on origins and first principle approaches by saying the data doesn't bear that. So we're starting to see the same analogy in terms of the data we're starting to collect. Now let's also be clear, we saw that the AI routines ingest huge amounts of data. So another challenge we have is, in order to take full advantage of those things, we're going to have to collect reams and reams more data. And guess what? I can't collect it by human means. So that leads us into autonomy. So the kinds of things we look at in here in terms of the technologies are going to have to be those convergence of technologies. So no one single solution is the answer. It is about a convergence of the technologies. So the kinds of lenses we use in our team are things around autonomy and autonomous machines and robotics for the data collection for those kinds of things. We look at next generation computers, photonics and quantum devices. We look at connected devices, which is our way of saying industrial IoT, but in a much broader scale. We look at something called intelligence. And by that, we mean these new AI approaches, the non-codified, the machine learnings, the neural net types of approaches, ultimately leading to cognitive. We're looking at quantum, because surprisingly, some of these things that are out there and still seem to be in the theoretical realm, a few little slivers come through that we could start taking advantage of today, particularly, say, in quantum sensors or quantum key, which may help us on our cyber side. We're certainly looking at blockchain, right? So we're clearly looking at those kinds of things. And then we're looking at some thematic things about what are the outcomes of some of those technologies to us in terms of the way, what is the future of work? Who are we going to actually consume for resources for work? Will it be robotic devices we'll consume? Will we be engaging contracts with robots and RPA types of things in order to do it? So there's this concept of a digital worker that's appeared in our context. And then we're looking at some creation of new opportunities from it. So this would be about, well, if electrification of the grid and the power stories we're hearing and all these things are disrupting where our type of current energy we're producing is consumed, but remember, we do a lot of alternative as BP as well. So we are in the electric, we're in solar, we're in wind distribution and that. So some of the things I saw today, very intriguing to us. So with all of that in mind, we actually see new opportunities. So we're exploring with blockchain, for example, to say, what could that do to some of our trading, right? So we've got all these disruptive things. What are some new energy sources? Should we do something in power? So if we're kind of shifting the energy equation, our view is where do we put the energy? So in all of that, one of the things that is our biggest challenge is, again, you've got a culture that is heavily based on first principle science, heavily based on capital-intensive types of things, cycle times of 5 to 10 years, and yet the digital pace is doing this in between. So it's kind of like the frequency within a wave packet going down, right, an EM wave packet. So how do we actually make the right choice on that? So part of the way we're looking at DNA here then is, what is that challenge of the workforce and the acceptance of this? Intriguingly, it's not just internal acceptance. And I think there was some allusion to it in some of the startup stories in here. So we're a highly regulated industry. Is industry going to accept us acquiring data this way? We see FAA, we see those other kinds of things about acquiring data this way, and we're regulating that. But more importantly, is industry going to endorse the outcome of an algorithm that said, here's your anomaly, and here's the remediation we're going to recommend? Because right now, that's all human-based outcome. It's all analyzed there. So we have this notion of not just the DNA of our industry, of our company to change, but we have to change the DNA of the outside world, including even some of our stakeholders. So in other words, if I'm flying over land, am I allowed to do that now if I had surface rights? And I take a drone across somebody's land. So, some things about the privacy laws and that, about people saying these new acquisition sources. So in terms of where we come in as our team, so I'm a member of a very small team. We're called the Digital Innovation Organization. We started 3 years ago around this time that this whole realization of digital being a massive one of the massive planks of changing the transformation of the company. We actually started with our group, so we're very small. And our remit is those technology space IoT, and it's about visioning the future and then bringing it back to the present, and which ones scale. So the difference is our challenge and part of our role is to give some advice and counsel all the way from our board level down in terms of what are the technologies that would make sense for us to look at, invest in, and which ones can scale and we can leverage starting today? Which ones do we still have to do research? So our second remit is we have a mandate to look at research and investigation into some of these emerging ones and saying, are they showing the promise? So for example, we call it quantum readiness. I think we found the Tesla. So we went and looked and found Tesla. I'm sorry, did anybody get that joke? No, it was a bad one, but sorry, we found the Tesla. So just as some examples of what we've been able to do today, a lot of what is beautiful about some of this new technology is safety has always been our #1 prime goal. So the notion is if I can't acquire enough data to feed these new algorithms and these new approaches through human means, and I have to resort to some, say, sort of autonomous means, what's the benefit of that? Well, a natural side effect is safety immediately. I'm not putting people on ropes. I'm not putting people underwater. So here's an example. I've got a few examples of these things where when we have to put people in these particular locations to gather data or do some mundane work, it costs us a lot of money because of all the protocols we want to put in place to make sure they are as safe as possible. So things like diver time, maximum 49 minutes per dive. We have to have baroscopes in place on the ships just in case they get the bans, and we have to have all these other safety protocols associated with it. All of these things to put the layers around this are dramatic in terms of the cost of performing the operation and our ability to perform the operation in how much time. We're affected by sea state. We're affected by all these kinds of things. And of course, what you can do now is you can start using some of these autonomous approaches, and you can start dramatically changing the equations in the safety space first, which is what our prime concern was, but now in the ability to cover and acquire the data we need for the AI is significant. So these are some of the things here, but let me point out one more thing. We saw some great stuff from the groups out here right now, and I think that's fantastic because you're seeing in some cases a bit of getting to, say, 1.5G, 1.5 generations into some of these approaches and use cases that we could take advantage of. But our job in our organization is to say, where does it really end? What is that possible future? So we envision, and we have invested in Beyond Limits, which were the ones who did the technology for the Curiosity rover, the 7 Minutes of Terror video, if you've ever seen that, excellent video, of how can you build autonomy into something so far away that you'll have no clue what it's going to encounter. How do you create autonomy in a cognitive sense? So we've actually invested in Beyond Limits and now starting to explore in the early days, what do we do to add cognitive? So if you look at everything I've just described to date, or we see to date in the starting world, it's more about collecting data and analyzing and giving insight into data. It's not about letting these things actuate, take action based on that data yet. We're not yet in a position to trust. So that's one way of looking at what do we mean by cognitive. So I'm going to conclude there and say, if anything, we absolutely believe in a digitalization. We believe in the promise of the future of it, and we're aggressively pursuing that. So thanks for listening.
Yeah. And we're going to take maybe 2 questions. Dave, do you want to throw it?
Yeah, well, I don't want to throw
Who
it
dares to raise their hand?
There's one over there. Here we go. Sorry, it was a test.
I'm really glad that you touched on the point of regulation. Oh, sorry. I'm really glad that you touched on the point of regulation and how it's really, in order for big companies to adopt something like that, the regulation needs to be there. So can you talk more about what do the new algorithms and what do these approaches need to do in order to strike a nerve or strike a chord with the regulators and allow companies like yours a broader adoption of these technologies?
I think it's more of not having the algorithms do more, it's having the outcome of the algorithm be accepted. So it's around the word trust to say, and we heard some comments about 99.5% accuracy as compared to traditional mechanisms or something. So that's something that we have to use and overcome and get in with the regulators. So I think it's not that we can't show these are the outcomes. We have to get them to say it's as good as or better than what we've been doing in the past. Now remember, at every step of the way in the past, it's primarily a series of steps where a human, a certified human with certified skills, vets the outputs, the outcome, the remediation, and a final person says, I sign off on everything, just like in an engineering project. And then that's accepted by the regulatory agency. So that's our challenge. How do we now say, if all of that occurs in a very short period of time, because remember, our goal is, I want this actually giving me these outcomes and insights while I'm capturing the data at the edge. We're not there yet, but that's what I wanted to do. Someone to accept that and say, I will accept that outcome for you. So it's a trust thing in my mind more than anything else.
One more.
One more? Okay, here we go. See, I threw that one better. It's not a hockey puck.
I almost got hit now. I don't want to talk about it. I broke my hand. But the comment about regulatory space sparked my question. I'm in the nuclear industry, right? So we were actively involved in figuring out how to mitigate cyber risk. So I guess my question is, how would you do that in an O&G and on a platform? You know what, on a platform is not really a problem. You got other problems if somebody's, but in a processing plant. I had a very sobering tour at Idaho National Lab.
Question, please.
How is it integrated, cybersecurity, in your implementation?
So the answer is yes. So the answer is yes, but no. So what I believe is we're in a death spiral of cybersecurity. So all of the technology we're seeing are based on an extremely untrusted world and ever-increasing untrusted world. So we're introducing more business latency into our processing by running these algorithms to say, is it safe to actually press the button? So we're doing all kinds of honeypot and other kinds of approaches to say, almost mimicking our entire environment to see what the hell happens and say, okay, it looks like it's safe now. So is there a way of using these new technologies to actually reverse it, or at least raise the barriers to entry for cybersecurity? Anybody can get into cybersecurity right now. There is no barrier to entry. But perhaps through the promise of, say, approaches like blockchain and quantum key, we could get to a place where we really raise the barrier there. So that's what I meant by, yes, we're aggressively pursuing what we already know, but the real goal is to say, can we actually change dramatically our view of how we do that? Okay? Hope that answered it.
Yeah. Let's thank Dave. Thank you very much. Great presentation.